In this video, we're going to be looking at how to find the distance between 2 points on a grid, and then we're also going to look at how we can do this without using a diagram and just using the coordinates of the points. Let's get started on this first one. We need to find the length of the line segment FG, so that is this line segment here. We're going to find this length using Pythagoras' theorem. Notice that to go from F to G, we are actually going 3 units across and 3 units up. Now, if you're familiar with Pythagoras' theorem, you can very easily find this length here. If you're not sure about Pythagoras' theorem, go and check out topic G11a. If you are familiar with Pythagoras' theorem, you'll know that 3 squared plus 3 squared will give us this length squared. So to get just the length FG, we need to square root that. Now 3 squared is 9, so 3 squared plus 3 squared is 18. So the length of FG is the square root of 18. This can be simplified to 3 root 2. So its length is 3 root 2 units, where a unit is just the length of the sides of one of these squares here. Let's move on to the next example. In example B, we need to find the length of the line segment FH. So that's this line segment here. Pause the video and see if you can work out this length. Here's what you should have found. We've got a right angled triangle here where the shorter sides have lengths 6 and 4. To find the hypotenuse, we need to work out 6 squared plus 4 squared and then find the square root of that. Now 6 squared is 36 and 4 squared is 16. So we've got the square root of 36 plus 16. When we add those up, we get 52. So that's the square root of 52. And we can simplify that third. It simplifies to 2 root 13. Now, before we move on, I want to look at how we could do this question if we didn't have this diagram and only had the coordinates of the points F and H. You see, the diagram here made it really easy for us to see that our right angled triangle had shorter sides with lengths 6 and 4. But what if we didn't have the diagram? Well, let's consider the coordinates of these 2 points, F and H. Notice that this horizontal distance here is simply the difference between the x coordinates. The difference between 2 and -4 is 6. Also, notice that this vertical distance here is just the difference between the y coordinates. The difference between 1 and 5 is 4. Using this knowledge, we can find the length of a line segment between 2 points if we're given their coordinates. We only need their coordinates, we don't actually need a whole diagram, because we know the horizontal distance between them will be the difference between the x coordinates, and we know that the vertical distance between them will be the difference between the y coordinates. And your horizontal and vertical distances will form a right angled triangle on which we can use Pythagoras' theorem. Here's the last example. Now, we're going to try and do this without using the diagram. Instead, I'm just going to give you the coordinates of G and H. Right, where do we begin? Let's consider the horizontal distance between G and H. That is the difference between the x coordinates, 5 and -4. The difference between those is 9. Now, let's consider the vertical distance between G and H. That is just going to be the difference between the y coordinates. Now, the difference between 4 and 5 is just 1. So, we have a horizontal distance of 9 and a vertical distance of 1. A horizontal and a vertical will form a right angle. So we've got a right angle triangle with sides of 9 and 1, and The length GH is our hypotenuse. To find the length of that hypotenuse then, we need to work out 9 squared plus 1 squared and find the square root of that. Now what we've got in here is 9 squared, which is 81, plus 1 squared, which is just 1. So this gives us the square root of 82. Now this is a surd, which can't be simplified further, so I'm just going to leave my answer at that. Just to help you see what's going on, let's look back at the original diagram. Now here's the actual triangle we were considering. We calculated this length of 9 by finding the difference between 5 and -4, and we calculated this length here of 1 by finding the difference between 4 and 5.